Hey guys, today we are going to be doing a Chapter 11 Properties of Solution problem. It's sort of like a recap of what we learned in the earlier chapters. Let's get straight to it. So this problem says, an aqueous solution of hydrochloric acid has a density of 1.19 grams per centimeters cubed and a mass percent of the solute of 38%. Calculate the molarity and the mole fraction. So the first way I sort of approach this problem is I start by saying that the 38% is equivalent to 38 grams of hydrochloric acid over the 100 grams of solution. This is what the 38% means. So now I need to solve for the molarity. Calculate the molarity. Molarity is equal to moles over liters. So I have to find out how many moles are in 38 grams of hydrochloric acid. Well, it's a little grams to moles problem, so 38 grams of HCl, and hydrochloric acid's molar mass is 36.5 grams of HCl, and that will give you the amount of moles to be 1.04 moles HCl. Now, you have to find the liters. In order to solve for liters, you have to use the formula density equals mass over volume. And our density is given to us to equal 1.19 grams per cubic centimeter. And that is going to be equal to 100 grams of the solution, which is the mass, right? In the density over mass volume, over volume, because we're solving for volume in order to solve for the molarity. So that means that the volume is going to basically be equal to 100 grams of solution divided by 1.19 grams per centimeters cubed. I'm not really writing the units because they cancel out in the manner that we need them to. And this gives you a mass of a volume of 84.033 milliliters, and for mole calculations it needs to be in liters, so divide by 1,000 and you will get your volume to be 0.08433 liters. Now you have to solve for the molarity. So it's a simple plug-in now. The molarity is going to equal 1.04 moles of HCl, which we found right here, divided by 0.08433 liters, which will give you a molarity of 12.40 molar. And that is the molarity for HCl. Now, we have to solve for the mole fraction. Okay, I'm going to make this a little smaller so I can make room for the mole fraction. Okay. Now, the mole fraction, it has a specified formula. The mole fraction's formula I'm going to put A, moles of A, over, I'm just going to assume there's two products in here. This is how I like to think of it, mole A plus mole B, and it applies here because we have water and hydrochloric acid. Now, in order to solve for the mole fraction, clearly we need this mole B. Mole B is the number of moles of water in the solution. And we found out that there's 38% hydrochloric acid, which means that 1 minus this 38% is going to equal the percent of water, right? So 1 minus 38% to give you 62%, which means that 62 grams of this solution are water. Now we have to convert this to moles. In order to do so, we are just going to take the 62 grams and put it over the molar mass of water, which is 18.0 grams of H2O, to give you a value of 3.44 moles of water here. Your mole fraction is going to be this plus this mole you found right here. And since you're solving, this is going to be your divisor. So you're solving for the mole fraction of HCl. So it's going to be equal to 1.04 moles of HCl over 1.04 plus the 3.44 moles of H2O, because you're basically solving for this segment. So it's kind of similar to like mass percents and things like that, but instead of mass, it's moles. So this is going to give you 0.232, and mole fraction does not have a unit. And this is your answer.